Hello, my name is Mike Coffey. I'm a VDOT. I'm the district construction engineer in Fredericksburg, but I've got a long history with full depth reclamation, and in particular, the mix design. So in the VDOT world, we generally, before the contract is advertised, determine the depth of reclamation and generally what type of agent we're going to use to stabilize it. Once the job's awarded, the mix design becomes the responsibility of the contractor, and they'll hire a consulting firm to sample and do a mix design. And that's our subject. So objectives, get a basic understanding of the mix design, discuss the stabilizing agents, talk about field sampling, that's very important, and then that's the actual mix designs. And I'll share a lot of lessons learned, my mistakes over the years that I've learned from. So the actual process, we've got a reclamation drum, we've got our asphalt, our aggregate, and our subgrade. So for the mix design, we're trying to replicate this field process in the laboratory ahead of time. And it's not easy. So ways to stabilize. There's mechanical, bituminous, and chemical. Chemical is generally lime, cement. We'll talk about each. So mechanical, we're going to go ahead and add aggregate, get some big particles in there. And it can be RAP, it can be 21A. Bituminous, we've all seen asphalt emulsion, asphalt suspended in water. You blend that into your reclaim layer. Foam's a little more rare. I try to image it like a cappuccino machine. You have a hot jet of asphalt, hot jet of water. When they combine, it froths and foams, and that's blended into the aggregate and soil. Cement is the most common. It's very forgiving, works with lots of soil types. Lime use a little less of. Lime's more applicable to very fine-grained soils, silts and clays. Fly ash, very seldom used. Fly ash is a byproduct of the coal industry. It has pozzolans which react with soil to form like a sort of a cement. Along the lines of fly ash, there's a product called lime kiln dust, and it's a byproduct of the lime industry. That's used occasionally. It actually works fairly well. And then you can blend. I've blended lots of times. I've had soil that was very wet, so I've hit it with lime first to dry back, and then use cement to actually stabilize it. I've used lime kiln dust with cement. So lots of options, lots of tools. You can first mechanically stabilize, add RAP, and then add cement. People use asphalt emulsions with a little bit of Portland cement to help get a quick set. So lots of tools in the toolbox. So this is a good flow chart. I'm not sure how many of you are familiar with soil classifications, but we start here with a GW, which is the most granular. It's a well-graded gravel, to over here, which is a CH, highly plastic clay. Here we have emulsion asphalt, foamed asphalt, Portland cement, and lime. So they all have limitations based on grain size. Cement really runs the gamut. Although it says you can't use it for MH and CH silts and clays, I have successfully. Again, sometimes I might hit it with lime first, just to change the properties of the soil, and then use cement. Foam is very limited to a very well-graded coarse material. So the mix design submittal, it's a very important document. This document really guides the entire mix design process. Important to note, has to be submitted to the engineer, VDOT, 30 working days prior to the start of work. So that's 6 weeks. A lot of time to build into your schedule. Mix design submittal shall have at a minimum your target field density. That'll be your proctors for your stabilized material. Percent weight of the agent, whether it's 4% cement, 5%, 6%. The percent water required, moisture content of your mix, very important. The expansion ratio and half-life characteristics and temperature of asphalt binder at the time of injection in the foaming. Again, we don't do a whole lot of foam asphalt, FDR, but that is in there. Minimum cure set time for asphalt emulsion. This is hugely important for emulsion projects because it can take a while to set based on outside temperatures, humidity, weather. temperature of the asphalt emulsion at the time of incorporating it into the mixture, and target gradation. So I always say in my project, start right, end right. I have a project meeting, and all our jobs usually start off with a big pre-con with lots of people, 30 or 40 people. I'm not talking about that meeting. Have a separate meeting with your contractor, their engineer, VDOT. We can sit down at a table and talk about the project. Lots of good things can come out of this. Oftentimes our contracts and plans aren't perfect. A lot of good ideas can come out of these meetings about traffic control, means and methods. Lots of great ideas can be talked about. Again, the mixed design is critical path. Nothing can happen until this is done, so it's got to get done right the first time. There's no mulligans with this mixed design. You've got a start date and a fixed completion date. And this is critical path to getting the job going. Things to talk about: project length. How many samples do you need? You discuss traffic control for both sampling and the project. This sometimes overwhelms the lab, is the amount of sample size and containers needed. It's a lot of samples. We'll talk about that later on. Roadway stationing. Oftentimes these plans don't come with stations. So someone has to get out there with a roller and mark off stations so you can identify sample locations. And you got to talk about roadway patching. You're going to be taking a lot of samples out of this roadway, and it's a lot to go back in to patch these holes, more than you think. We'll talk about that too. Again, start right, end right. Communication is key. So again, the purpose, we're trying to reproduce this in the laboratory. Here's an example just to give you an idea of how much is required. So just to pick the typical 5-mile roadway, 2 lanes in each direction, I get my linear feet. So per our provision, you sample every 2,500 feet in each lane. So it grows exponentially. But kind of at the bottom is what I, 11 samples per lane, 4 lanes, 44 samples. Each one, you need about 3 buckets. So now you're talking 132 buckets of material. That's a lot of material. That's not one pickup truck, and that's a lot of stuff to go back in the roadway. So your consultant firm needs to plan accordingly for this operation. It can be a little overwhelming if you're not in front of it. And again, patching. Do you have enough 21A asphalt and a plate temper to go back in all these holes once you've taken out your asphalt and soil? This was a job we did a couple years ago in William County, Route 30, and the consultant came to us with their sampling plan for us to approve. So I've done lots of roadway sampling, and I had my lessons learned. So when I first started doing this, we'd go out there with a saw and chop out a block of asphalt and lug this thing back to the laboratory, and then figure out how are we going to break this thing up. So you put it in the oven, you start pulling it apart. It takes forever, it's inefficient. And at the end of the day, you're not replicating that blending action. This was a job we did this was the Blue Gray Parkway. On this job, Slurry actually brought out their small reclaimer. It worked great. We spent more time patching the hole than sampling. I think we did like 15 miles in one day. But you get a good representative sample of what you're actually going to be doing. Another great method, using an auger. I think VDOT, we copied this from North Carolina. Saw it first from them. We had when I was a consultant, we had a driller build one for us, and it works well. Blending operation as it goes down to a preset depth, but it's breaking it up very well. There's some loose, bigger pieces we'll pick out. As it's hitting dirt, it starts to change colors. Saves a lot of time in the laboratory. It gets you a good representative blend of what you're going to be working with. Again, start right, end right. You got to get with your laboratory early on to read all the various test standards. There's a lot of them, and you got to do them right. I always tell them, read them once, then sit down and read them again because they change. And it often expands. So this is ASTM 1632. It's how to making and carrying soil cement, compressed and flexural specimens. When you read this, it refers to other test methods as part of the process. Ensure this lab has adequate staff and handle the project. This has been a huge issue for any lab. These jobs generally occur during the construction season, April through winter, when all labs are at their busiest. So when all of a sudden 132 buckets of material come into a lab, they're just overwhelmed. They don't have the staff for it. They have to decide which job gets put on hold to rush these samples through. So make sure your lab can bring in extra resources of people. Equipment. Do they have enough equipment to get all these processed? Shelving, you bring in 132 buckets, it'll take up your floor space. Without shelving and adequate pans to get them all out, it's going to be overwhelming. Very important, ensure a proper curing room is available. I'll talk about this later on, but these specimens, this is an actual specimen from the Blue Ridge Parkway. They're cured in a moisture room, not in a tank. A lot of labs don't have wet rooms. And I'll talk later, but ensure they have the proper compressive strength testing equipment. So this is straight from our special provision. It just lists the tests, the general tests that are required. But as I mentioned, each test has got sub-tests, specifications that are tied to them. So ASTM 1633 is for the actual compressor strength. But in order to do this, you have to do it in accordance with 1632, which references D 1690. Lots of test standards that kind of tie together. And like I said, you read them once, you kind of get an idea. You got to sit down and read them again and again to make sure all your staff understand the specimens. These are some photographs of a laboratory that used to work for me. One of the things I wanted to point in this picture is sample management. You've got a lot of samples. You got to keep them numbered. Here they've got wire tags with these duct tape for a tag. But once they go to compressive strength testing, you can't have that, so you have to transfer a different number onto them. So laboratory management's important. So one of our important tests is gradation. Right now we have 2 specs with VDOT, 100% passing the 2-inch, and then at least 55% passing the 3/8 sieve. Moisture density relationship of soil cement mixtures. Generally we run 4, 5, and 6%. And oftentimes it comes out in this range for most soils. So this is the important test. So we're looking for a very low compressive strength, 250 to 450 PSI. We don't want a very strong concrete slab. We want it to be low strength. A minimum of 2 samples, pills per cement. So you'd have 2 of these per cement content. Method A really dictates the size. That size sample. That's how you prepare them. So this is one that often snags a lot of labs. This uses all material passing the 3/4 sieve. Most labs are ingrained in their head to basically sieve out everything that's retained in the number 4 sieve, which is 3/16. This is a lot different. The big aggregate remains in the sample. Very important, you have to get it at optimum moisture. You do not want it dry of optimum. This one also snag a lot of people. So when this is made, we're making it in 3 layers. You're going to compact a layer, and then between each layer, you have to scarify them. Take your tools and just rough the surface up. You don't want to induce any shear planes in your sample. And again, it has to be in a moisture room, protected from free water. So basically, you should put them in the moisture room with a little bag over top of them so water couldn't drip on them, but it's still like 99% humidity. And this is important. A lot of labs don't do this. So once you're ready to sample it, you soak that in water for 4 hours. So you want to replicate worst case scenario in the field. You want to assume that you're subgrading your field, or when that's in the field completed, is 100% saturated, worst possible condition. And then you want to cap them. Sulfur caps work best. Load applied at 0.05 inches per minute. So a hand crank machine, you really can't get this load rate. It almost has to be a computerized speed control for your compressor strength machines. So you're only applying about 3,000 to 4,000 pounds to that. And this is another big issue. So a lot of labs, all they have is a great big concrete testing machine. It's a 500,000 pound load cell. Those things are often not calibrated below 10,000 pounds. So when you try to use a big compressor machine, those things, your results are not very accurate. It's like driving a tack with a sledgehammer. I generally use a 10,000 pound load cell. Retained low results. When I've reviewed reports, I'll often see just weird anomalies. And oftentimes, if you can go back and look at that sample, you can figure out what it was. Maybe there was a weird piece of aggregate in the sample that made it break low. Another sample of just laboratory sample management, all well-labeled samples, trying to avoid mixing these things up, which can happen very easily. A nice picture of samples ready to be tested. You can see that they're wet. They just came out of the soak tank for 4 hours. They've been sulfur capped. They're all well labeled, so you're not going to mix up samples. This is a typical Humboldt load frame, 10,000 pound load cell. This is a measuring gauge to figure out the rate of loading. Great little piece of equipment. So this needs to be used in lieu of the big 500,000 pound concrete test machine. So back to our sample project. So 5 miles of roadway. We know we had 44 samples to collect. We're going to do 3 different mixed trials with 4%, 5%, and 6% cement. We end up with 264 pills. It's just, it grows exponentially. And the labs are often shocked at how big these jobs become rapidly. And again, this is all critical path. We can't start the job until this is done and done right. So make sure your lab can bring in additional staff and get it done.